Alright, so we're writing the equation for a parabola with a focus of -2, 5 and a directrix of x equals 4. So how does this open? Up, down, left, or right?
Left.
Opens to the left because you know your focus is at -2, 5 and your directrix is at x equals 4. And since your parabola can't cross the directrix, you know it's going to have to open this way. Okay, so this is roughly your picture. So how can we use this information to help us find our equation?
So you can find your vertex by looking at the focus, -2, 5, and then looking at your directrix, which is x equals 4. Since we're going to look at the x points, you find the distance between -2 and 4, which is 6. And since your vertex has to be equally distant from the directrix and focus, you divide it in half, which gives you 3 on both sides.
Okay, so does everybody understand that?
Yeah.
Does everybody understand that?
Yes.
Okay, so yes, you are looking at your x values here, 6 away from each other, so that's 3 and 3 from the vertex.
Then to find the vertex, the point in the middle, you add either 3 to -2 or subtract 3 from 4. And that will give you 1, 5.
Now why does the 5 stay the same? Why does the 5 stay the same?
Because it only affects your x values.
Because it only affects your x value. So 5 stays the same and your x becomes 1. Now on top of that, knowing that information and doing it this process, you actually know one other piece of information, which is what?
P.
P. Because P is the what? What does P represent?
The distance between the vertex and the distance between
The distance between the vertex and the directrix, and the distance between the vertex and the focus. So P is 3. But
P has to be negative since it's opening to the left, making your 3 negative.
it gotta be negative because it opens to the left. So my general equation is what? The general, before we plug in things.
y minus a squared equals 4p x minus a.
Alright, so how about this? Plug it in for me.
We have y minus 5 squared
Y minus 5 squared equal to -12x minus 1, and that is our equation there. Good job. Alright, that was just an extra assignment, so don't put this paper away. We're going to do some more problems that you're going to put on this paper. But back to your notes, we're going to look at some real world examples here, because parabolas are everywhere. If you ever noticed, in my classroom, there's a picture right there of a very famous, monument statue in St. Louis that models a parabola. Okay? So who knows? I might ask you to find the focus of that on your test. Who knows?
So what is the other picture you got?
There's other. Let's see. You got planes, horizontal lines, angles, circles, different things.
What about the windmills?
Angles. All right. So here's a real world example. It says the parabolic mirror for the California Institute of Technology Hales telescope at Mount Palomar has a shape modeled by this, where x and y are measured in inches. Now this right here is definitely a parabola that opens which way?
Left. Or right, right.
It opens to the right because your y's are being squared, and on top of that your p is positive. And you're being asked, what is the focal length of the mirror? The focal length. So what do you think I mean by that? P. The focal length. Okay? Because you're basically, what's the length from the vertex to the focus? The focal length. Now, what is the vertex in this problem?
What?
0, 0. And you know that because there's no additional y minus anything or x minus anything. So your vertex is at 0, 0. And you're trying to find P. How would I find P? Divide what number? Exactly. That 2668 is equal to the 4p in our standard form, so we divide by 4, and we will get our focal length, which is
667.
say it.
667.
And that is measured in inches. So our focal length is 667 667.
That wasn't too complicated.
Not too complicated.
It was just, I think, it was just learning the terminology for what equals what.
Exactly. Alright, look at the next example. The cross section. Now we talked about cross sections. That's where your parabolas and circles and ellipses and hyperbolas are created by basically the cross section between a plane and a double named cone. So the cross section of the image of a constellation can be modeled by this equation where x and y are measured in centimeters. Again, I'm asking you, what is the focal length here?
Negative 12 divided by 4.
Yes, question. One of these actually should be a y. And I did mess up there. Let me look and see which one of them should have been a y. Okay. Sorry, this one should have been a y. That was my mistake. So to find the focal length, you have to do what?
Divide negative 12 by 4.
You gotta divide negative 12 by 4 because this is the 4p in your general form. So p equals,
Negative 3.
now let's be real here, it would just be a positive 3 centimeters because we're talking about length here. You don't have such things as negative lengths. You can't have a negative side length. What does the negative actually tell you? The direction. Okay? And which way does this parabola open? It opens down because since p is negative, it opens down and your x's are being squared, so that supports the vertical notation. So, to recap, you guys have analyzed parabolas. What does it mean to analyze?
Tear apart.
Tear apart to find what?
Define the small.
Vertex, focus, axis, symmetry, and direction.
To find vertex, focus, axis, symmetry, and directrix. Okay, that was the goal. You were to be able to analyze that. Can you guys say successfully that you can analyze those 4 things? Okay. You also had to be able to graph these parabolas. Are you able to do that?
Yes.
How would you do it?
You'd use the vertex, directrix, axis of symmetry, and focus to graph your parabola.
You use those 4 things to graph it as well as
The x and y.
X and Y plot.
some x and y points. And then the last thing was to be able to write the equations. That's what we basically did today, yesterday for 3rd period. Okay?
Only to use like certain things that they give you, and still be able to write the equation.
Exactly. Taking the characteristics and writing the equation as well as going from any old form to standard form. You guys are able to do that now. Okay? So we have successfully completed the goal. All right?